Alright guys, today we're going to talk about exponential functions. So we've talked about linear functions, which are a line, quadratic functions, which are a parabola or a U-shape, and then exponentials are going to be our last function that we are going to discuss. Exponential functions, take on this form. F of x equals b, the base, raised to the x power. So you can see that we have an exponent here, which is why we call it exponential functions. So in this case we have an x in the exponent. Our first function is f of x, or I could say y equals 2x. That's our base function. Alright, and then, so from there, let's get our table of values. So all I'm asking you to do is to take this value, plug it in place of x. Right? So I'm plugging it into the exponent. So for negative 2, I would have 2 raised to the negative 2 power. Well, if you type that in your calculator, you're going to get positive 1/4, or 0.25. Same thing, I'm going to take this negative 1 and plug it in. That will give me a 1/2. Take the 0 and plug it in, 2 raised to the 0. Anything raised to the 0 power, guys, is going to be 1. 1, so 2 raised to the first power is 2. I'm going to plug in 2, 2 raised to the second power, or 2 squared is 4. So if I was to plot those on this graph, I would have negative 2 1/4, I would have negative 1 1/2, I would have 0 1, I would have 1 2, I would have 2 4. So my graph would take this shape. Now, this is a key point on the graph. We call that the initial value. The initial value, and that's the y-intercept. And in this case, it's going to be 0 1. And in a lot of cases, it's going to be 0 1. We also have another key feature on this graph, which is this dotted line right here. We call that the horizontal asymptote. Now, I know you have never heard of the word asymptote. Let's talk about what that is. Now, the horizontal asymptote is the line y equals 0, right? Because this line, the y-axis, is where y is equal to 0. What is an asymptote? An asymptote is an imaginary line that the function approaches but does not touch, and that's the key point there, as it heads toward infinity. So the key point is does not touch. Right? So it's going to get as close as it can to that line, but it's never going to touch it. It's never going to touch it. It's an asymptote. That graph, that function will never touch the asymptote. It's going to get very, 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 very close, but it's never going to touch. Now we have two types of exponential functions. We have an exponential growth and an exponential decay. Now, by intuition, growth is going to increase over time, and decay is going to decrease over time. Right? So in this case, in exponential growth, the quantity will increase over time. Sorry. And now, how do I get an exponential growth equation? It's where b is greater than 1. Now, again, you're saying, what is b? b is the base. Right? The base, and then you have the exponent. So whatever number that is of the base, which in this case it was a 2, if that is bigger than 1, it's going to be an exponential growth. And what that looks like is something like this. The quantity will grow exponentially over time, or increase over time. Now, the exact opposite is true for an exponential decay. The quantity will decrease over time. And what does that look like? Okay, it's going to look like this. The quantity will decrease over time. How does that happen? That is when b is in between 0 and 1, right? So b is a fraction. Again, what is the b? The b is the base, wherever that exponent is, which in this case it was a 2. So 2 is greater than 1, exponential growth, which is why we have a graph that goes up and increases over time. Because once again, this x-axis 99% of the time is going to be your time axis. So as we're increasing over time, the graph is going up. An exponential decay function, once again, if this is my time axis, will decrease or go down over time. And that's when b, the base, is in between 0 and 1. Let's look at some examples. Okay, so number one, I have the function 2 raised to the x power, which we just did. Okay, so 2 raised to the first power, if I was to find my table of values, you could just plug this into your calculator. You would get 1/4 or 0.25. You would get 1/2 or 0.5. You would get 0, 1, 1, 2, and 2 raised to the 4th. So now again, that y-intercept, or the initial value, is very important. That's at 0, 1. Looking at if this is a growth or decay, we're looking at the base. In this case, the base is 2, so b is equal to 2. So b is greater than 1. We know it's an exponential growth without even graphing it. Let's graph our points. So we have 1, 2. We have 2, 4. We have negative 1, 1/2. And then negative 1, 1/4. So our graph would look something like that. The domain is going to be all real numbers, right? The graph keeps going to the left. It keeps going to the right. All real numbers. The range, however, is going to be y is greater than 0. Because that graph has a horizontal asymptote at y equals 0. And again, a horizontal asymptote means that that graph is going to approach that line, but it's never going to touch it. Right? You can see that it's going to keep approaching, okay, but that decimal is going to keep getting smaller and smaller and smaller, but it's never going to be equal to 0. Now, why is that the case? Because there is no number that you can plug in place of x right here to make this 0. Because once again, this is y equals 2 raised to the x power. So there is no number that I can plug in for x to make y 0. Even if I plugged in 0 here, like I did, 2 raised to the 0 power is 1. Anything raised to the 0 power is 1. So there's no number that I can plug in to make y equal to 0. So it will never touch 0, which is why there's a horizontal asymptote there. All right, going to number 2. Number 2, you can see that we have a base, b, is equal to 3. So just by that, I know that this is a growth function, because b is greater than 1. Now let's find our table of values. Once again, all you have to do is plug this into your calculator. Type in 3 raised to the x power and go to your table. You would get 1/9, 1/3, 0, 1, 1/3, 2, 9. Now let's plot those points. Again, initial value of 0, 1, 1, 3, 2, 9. Once again, you have a growth function, looks like this. My horizontal asymptote is still at y equals 0, right? That graph is going to approach that line, never going to touch it. The initial value, or the y-intercept, is going to be 0, 1. My domain, same thing. It goes from negative infinity to positive infinity. We could say that is all real numbers. And then my range is the same thing. Y is greater than 0. Number 3. You can see that we have a fraction for my base. B is equal to 1/2, or 0.5. So in this case, B is between 0 and 1. So this is a decay function. All right, let's look at our table of values. Again, we can type this into our calculator. 1/2 raised to the x power. Find your table of values. You're going to get negative 2 fo, negative 1 dos, 0 uno, 1 1/2, or 0.5, and 2 1/4, or 0.25. So we have -2, 4, -1, 2, 0, 1, again initial value, 1 1/2, 2 1/4. So now my function looks like this. So you can see how it is the exact opposite of this. This increases over time, this decreases over time. Now looking at domain and range, it's the same thing. This still goes from negative infinity to positive infinity. So we still have all real numbers. The range is still everything above 0 on my y-axis. So y is greater than 0. The asymptote is still y equals 0. And the y-intercept, or the initial value, is still at 0, 1. Now, is this always going to be the case? No, this is not always going to be the case. Okay? For this, it is. Right? But if I were to throw a number in front of my base, then this stuff would change. Especially my y-intercept. Okay? Your domain, 99.99999% of the time is going to be all real numbers. Okay? 99.9999% of the time is going to be all real numbers, right? So once again, to recap, the parent function, y, or f of x, is raised to the bx power, and b is the base. That base is going to tell me whether it's an exponential growth or an exponential decay. If b, the base, is greater than 1, it's an exponential growth. And if b is less than 1, it's an exponential decay. That's it, folks.